3 of this worksheet. We're going to be determining if a reaction takes place and then predicting the products of the reaction. And if you take a look at these, all of these problems are either single replacement or double replacement. We have an element by itself plus a compound, or we have two compounds. So we're going to be limiting ourselves to single and double replacement reactions. This first one is a single replacement reaction. To find out if a single replacement reaction occurs, we use the activity series. We have two activity series. Activity series are for single replacement. Now, for this particular reaction, the thing that's by itself is bromine, which is a halogen. And bromine is going to be on our activity series of halogens. These are two separate activity series. We have our halogens, these four elements up here, and then we have our metals down here. So we find bromine, the halogen that's by itself, and we compare it to the halogen that's in the compound, chlorine. For a reaction to occur, the element by itself needs to be higher on the list. In this case, the element by itself is not higher than chlorine, it's lower than chlorine. So this reaction does not happen. So we just write NR for no reaction. For problem number 2, this is a double replacement reaction. For this one, it might be easier if we go in and figure out what it makes before we try to figure out if a reaction happens. Now, all double replacement reactions follow the same basic template. The template for double replacement reactions, as you can see on your reference tables down here, is that AB plus CD makes AD plus CB. In this problem, we'll just start labeling things. Calcium is A, chloride is B, potassium is C, bromide is D. It's going to be AB plus CD makes AD calcium bromide. Well, calcium is Ca, it's in group 2, so it's a plus 2 charge. Bromine is Br, it's a halogen in group 17, so its charge is minus 1. So if we get our charges written correctly, it's going to be CaBr2. Let me erase these charges so that you can see what's happening here. Plus Cb, potassium chloride. Potassium is plus 1, chloride is minus 1, so KCl. If we balance the equation, 2 chlorines, so we'll put a 2. We've got 2 bromines, put a 2, 2 potassiums. That looks balanced right there. Now the question is, does this reaction even happen? Well, for a reaction to happen, we need a precipitate, or something that is, according to our solubility rules, insoluble. So if we look at this here, calcium bromide. Well, the second rule over here says that all chlorides, bromides, and all iodides are soluble except silver, lead, and mercury. Well, what we need is something insoluble. These are our precipitates. Or we need to make water, and neither one of these looks like water to me. So calcium bromide is soluble because it's on the soluble side, it's not one of our exceptions. Then we have potassium chloride. Well, potassium, on our periodic table, if we recall, potassium is in group 1, and anything in group 1 is soluble. So since both of these are soluble, we went to all this trouble for nothing, because this is no reaction. Now, not everything's going to be no reaction. Like, let's take a look at number 3. CuCl2 plus LiOH. Well, this is AB plus CD. That's going to make AD we've got copper, and we've got hydroxide. Well, I know from looking at the reference tables that hydroxide has a charge of -1. Now to figure out the charge of copper, we're going to have to work and figure out what its charge was over here. This is a more complicated problem. We don't know the charge of copper because copper, if you'll recall, is a transition metal. It can have multiple charges. But in this compound it was bonded with chlorine, and chlorine we know has a -1 charge. So if chlorine was a -1 and we had 2 of them, then copper must be a +2. So over here copper is also going to be a +2. So we need 2 of our hydroxides at -1. It's copper 2 hydroxide. The other product we're going to make, according to our template, is Cb. It's going to be lithium chloride. Lithium is a +1 charge. Chlorine is -1 charge, so it's just LiCl. To balance this equation, we have 2 chlorines on the left, 1 on the right, so we'll put a 2 right there. That gives us 2 lithiums and 1 lithium, so we'll put a 2 right there. And 2 hydroxides, 2 hydroxides. It's balanced. Now, we need to see if we make a precipitate. Well, this first thing right here is copper 2 hydroxide. And this rule says all hydroxides are insoluble, except group 1. Well, copper's not in group 1, copper's in group 11. Strontium, barium, and ammonium. This is not any of our exceptions. So this right here is our precipitate. So I'm just going to put a little line under that. We know we have a reaction. We've made a precipitate. Number 4, we're changing gears back. This is a single replacement reaction because we've got fluorine by itself. So we need to consult our activity series. Is the thing by itself, fluorine, higher than something else on this list? We're not going to compare lithium because that's in the other activity series. We're going to compare it to iodine. Fluorine's higher than iodine because fluorine's at the top of the list. So fluorine will replace iodine. So if fluorine was the single element by itself, iodine will be the single element by itself on the other side. That's why it's single replacement. Except remember, iodine is one of our diatomic elements. They clue you in with the little 2 right there. So when it's by itself, it's I2. And then we're going to make lithium, and we're going to combine lithium with fluorine. We always write the metal first. Lithium's a +1 charge, fluorine's a -1 charge, so it's just LiF. Now, I know there was a 2 over here. We don't just stick a 2 down here. The 2 goes out in front to balance it with another 2 right there. So that's another single replacement. Number 5, we're back to double replacement. Keeping you on your toes here. Sodium hydroxide, Ab, plus hydrogen chloride, Cd, makes Ad. Let's see, sodium is +1, chlorine's -1, so it's NaCl, plus HOH, hydrogen's a +1, hydroxide's a -1, HOH. Also known as water. Now, when you make water, that's just as good as making a precipitate. The reaction happens. And this one is already balanced. So we're done with number 5. That one was easy. If you remember that water makes a reaction happen. Number 6. We're back to single replacements, but this one involves a metal. We haven't done one of those yet. So here, the element by itself is zinc. So we'll find zinc on our activity series. It looks like it's right here. And we're going to compare it to the element that's in the compound, chromium, which is right below it. Since the element by itself is higher than the one that's in the compound, a reaction happens. So we're going to make a compound between zinc and chlorine. Now if you'll remember, zinc always has a +2 charge. Let's see, my pencil just broke there. Zinc is always a +2 charge. Chlorine's a -1, so it's ZnCl2. And then we get chromium by itself. Now to balance this equation, the only thing that's different are the chlorines. We got 3 over here and 2 over here. So we put a 3 out in front there, a 2 there. That gives us 2 zincs, so we put a 2. And 3 chromiums, we'll put a 3. Moving on to number 7. Platinum plus iron 2 nitrate. Another single replacement reaction. Platinum is the next to last element on the list. Since we're not reacting it with a gold compound, that iron is way higher. The thing that's in the compound is higher. So this is no reaction. We don't even have to do anything else but that. Number 8. Cobalt dichromate plus sodium. This looks like a single replacement reaction, except this time I wrote the thing that was by itself second. Don't let that trick you up. But sodium, if we check the activity series, sodium's up here, cobalt is down here, the thing by itself is higher, the sodium, so we get a reaction. So we're going to react sodium with the dichromate. Sodium is a +1 charge. Dichromate, one we don't use a whole lot in this class. It's extremely dangerous and cancerous, carcinogenic. Dichromate has a -2 charge. So to balance the charges of +1 and -2, we put a 2 down there by the sodium, and then we get cobalt all by itself. So the only thing I need to do to balance this equation, it looks like, is put a 2 in front of the sodium on that side. Now, for number 9. Sodium phosphate plus ammonium hydroxide, AB plus CD. This is a double replacement. That's going to make sodium hydroxide and ammonium phosphate. That's going to make sodium hydroxide plus ammonium, which is a +1 charge. Phosphate was a -3, so we need 3 of those. If we balanced this, put a 3 there and a 3 there. But now we need to see, does this reaction even happen? We may should have checked before we bothered to balance. So we need a precipitate. Well, this is, even though this says hydroxides over here are insoluble, this says except group 1. If you remember, everything in group 1, like sodium is soluble. And then ammonium, all ammonium compounds are soluble. So we don't have a precipitate. This is no reaction. This reaction does not happen. Last one. Sodium oxide plus strontium acetate. This is another one of these double replacement reactions. AB plus CD makes AD plus CB. This is going to make sodium acetate. Sodium's a +1 charge. Acetate is a -1 charge. Plus we're going to make strontium oxide. Strontium's a +2, oxygen's a -2, SRO. Now we need a precipitate. All acetates and group 1 compounds like sodium are soluble. That's not our precipitate. But then we have strontium oxide. All oxides are soluble except group 1. So this is insoluble. This is our precipitate. We have a reaction. And that concludes part 3 of the worksheet.